All right, for this section, guys, we're going to talk about VA-4, which is congruent and similar triangles. This is going to be done on a coordinate plane. So, when we're talking about congruent and similar triangles, we're going to use side-side-side congruence or side-side-side similarity, which means we need to find the length of every side. And as we know, another word for length is simply distance. So we would do the square root of x minus x squared plus y minus y squared. And we're going to do that multiple times for these problems. So what I'll do is I'll do at least one or two examples for each one, and then we'll shorten it by the skipping, all right? So we need to first figure out the length of AB, which is the first side of your triangle, which is over here, right? So we need to figure out the length of that. So if I'm going to find AB, then I'm going to use the distance formula and say my two x's are 2 and 4. So 2 minus 4 squared plus, and then my two y's are 5 and 2, so 5 minus 2 squared. All right? So 2 minus 4 gives me -2. -2 squared is 4. 5 minus 2 is 3. 3 squared is 9. We add those together, we get the square root of 13. Now, for my purposes, I'm actually going to stop right there. So I know AB equals the square root of 13. And the reason why is when we do the other one, it should match it. So it should match DE in the other one, right? So D and E are those 2 points. We're going to do that over here on this side. So DE equals the square root of, my two x's are -3 and -5. So -3 minus -5 squared, plus my two y's are 3 and 0, so 3 minus 0 squared. If I do -3 minus -5, I get a +2, right? 2 squared is 4. 3 minus 0 is 3. 3 squared is 9, so I get the square root of 13. So what you should notice at this point is that these two things are equal, which means the first set of sides are congruent, so they match up. What I'm going to do here is I'm going to pause it. I'm going to do the distance for BC and EF, and then we're also going to do the distance for AC and DF, all right? So I'm going to pause it here. You'll see it pop up here shortly. All right, so now I've done the distance formula for BC. I've done the distance formula for EF. That says BC, it should say EF. And we've done the distance formula for AC, and we've done the distance formula for DF, all right? So what you should notice at this point is AB equals the square root of 13, and DE equals the square root of 13. So those two are congruent. BC equals the square root of 18, and EF equals the square root of 18. So those two match. And then AC equals the square root of 37, and DF equals the square root of 37. So we have 3 sets of sides that are congruent. So when they asked us to prove that, we now know that those two are congruent. So the answer would be yes by side, 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 because we just made sure all the sides were congruent, all right? Now, for our next one, we need to prove that they are similar. To be that similar, instead of the sides being congruent, they need to be proportional. So once we get all of these, we need to set them up as fractions and make sure they are equal. So again, I'm going to do the distance formula for the first set of sides, and then I'll pause it and do the others. So let's do RS first. RS equals the square root of 0 minus -4 squared plus 2 minus 6 squared. All right? So we go ahead and clean that up. 0 minus -4 is 4. 4 squared is 16. 2 minus 6 is -4. -4 squared is 16. So RS equals the square root of 32. Now, for this one, you can either leave it this way, but it's actually easier to turn that into the decimal, which would be that RS equals 5.66. All right? Now, we need to do the same thing for XY. So over here, I'm going to do XY, and we get the square root of, my two x's are 1 and 3, so 1 minus 3 squared, plus my two y's are going to be -2 and 0, so -2 minus 0 squared. So we get that XY equals 1 minus 3 is -2, -2 squared is 4. All right? -2 plus 0 is -2, -2 squared again is 4. So we get that XY equals the square root of 8. Now we can go ahead and turn that into a decimal, and XY equals 3.61. or excuse me, sorry, that's wrong. It's actually, I was looking at the wrong problem there because that was one from before. It's actually 2.83, excuse me. All right, so here I'm going to pause it. I'm going to do the distance formula for the other 4 sets of sides, and then we'll compare them here briefly. All right, so now that we have the distance formula done for all 3 sides of each triangle, now we need to set up our proportion. So we're going to take the 5.66 and we're going to put it over top of the 2.83 because those are the ones that match, right? Then we're going to take the 4.47 and we're going to put it over 2.24. And last, we're going to take 6 and put it over 3. And what we need to do is we need to put all of those in our calculator and reduce them one at a time. If we reduce the first one, we get 2. If we reduce the second one, we also get 2. And if we reduce 6 over 3, we would get 2 as well. Now, you'll notice that for some of these, like the second one, you would have gotten 1.9955. We're going to round it. And the only reason we're okay to round it right now is because it's actually a rounded answer previously. So that's the one time that I'll say that you can get away with that. Now, if all 3 of these sides are proportional, then we now know that these triangles are similar. So yes, by side, side, side similarity. So these problems really aren't that bad. It's just a lot of work with the distance formula, but other than that, they're pretty easy, all right? So make sure that you have these notes filled in, and we'll see you next class.